In chaos lies opportunity. Today, I'm going to share with you a story where fake news created purpose in heart. My story started as a 15-year-old boy growing up in Ghana, West Africa, and glued to the evening news channel one fateful night, where the news reporter passionately reports to crowdfund to surgically save a life of an 8-year-old girl diagnosed with a hole in heart condition. In my naive teenage mind, this was fake news and gave it no attention. Fast forward, I go to college and I develop a deep inquisitiveness on how human organs are formed. It first started by researching human limbs development. That's the hands and the legs. And today, I focus on heart development. You may say, that's strange, or he became a believer. I prefer to be described by the latter. The human heart is a very complex organ with 4 chambers and its corresponding valves. Blood moves into the heart through 2 major veins called the pulmonary vein and the vena cava. Blood then navigates through the various chambers of the heart, which are under the influence of respective valves, then eventually exits the heart through the pulmonary artery and the aorta. This only happens when the heart is properly formed. However, in some instances, the heart is improperly formed, resulting in leaky valves, hole in heart, and defective vessels. Heart malformation comes in different forms and is collectively known in the medical world as congenital heart defect, which contributes to 30% of the infantile mortalities annually and currently can be repaired by surgery. The current surgical repair approach has saved more lives than I myself can even number. However, it is flagged by the aftermath of adverse effect, constant medical intervention, and in some cases, restraint on certain physical engagements. At this point, I want to advise the audience that I'm going to show you a photo. It contains some disturbing features, so please be advised. This is a photo of a 3-month-old baby who had just been subjected to an open heart surgery to repair his heart. I just want you to think about the ordeal this baby and the family had to endure during this phase. And mind you, this baby will need to have this scar for the rest of his life. This and many other types triggered conversation within the scientific space to better understand the root cause of this condition and hopefully come up with a better alternative. And after long hours of working, scientists discovered zebrafish as a powerful tool because the heart development in humans is very, very similar to that of zebrafish. And again, zebrafish have a transparent skin that allows us to observe the development of the heart in real time. So no need for surgeries. That's good news. So the goal here is simple. It's to use zebrafish to understand and define the root cause of congenital heart defect. And my main purpose is to use zebrafish to understand at the molecular and cellular level how a unique structure of the heart called the outflow tract it develops. To provide some perspective, the zebrafish heart as shown here receives blood at a junction known as the venous flow at the inflow tract regeneration, which is marked as IFT. Blood then moves into the atrium under the influence of a valve known as the atrioventricular canal. The opening of this canal moves blood into the ventricle, then eventually exits the heart at the atrial pole via the outflow tract. You could see here, the zebrafish heart is very, very different from humans. Very, very simple, but the process is still the same. If you take a deep dive into the composition of the outflow tract, it consists of myocardial cells, that are cardiac muscle cells, endocardial cells, which are cardiac lining cells, and smooth muscles that provide elasticity to the outflow tract. In a much more complex human heart system, just as you and I have it, the outflow tract develops into the aorta and the pulmonary artery. These are major vessels that transport blood away from the heart. So, if you have a defective outflow tract, blood is remaining in the heart, depriving other organs of the blood they need to perform their functions. So this is very, very important. So this is what I did. I acquired 2 groups of fish, one in the disease state and one as a control group. And my disease fish, I call them pendulum, or pen for short. My control as sibling. At a time point of 72 hours post-fertilization, where outflow tract formation is evident. And you could see here that in the SIB group, as shown in panel A, there is an intact smooth muscle cell structure as stained in green and pointed by the arrow, with a normal ventricular cell structure as stained in red. However, in the pen group, we encounter an opposing narrative, where approximately 30% have completely lost their smooth muscle cell structure, as shown in panel B, with the other 70 having a reduced smooth muscle structure, as shown in panel C. You may wonder, what is then happening to the myocardium and endocardial cell population? We then dived into that, and we could see an intact myocardial population in both groups, with an excessive endocardial population in the pendulum group. This then also generated a lot of conversation. What probably is wrong? Then we figured, congenital heart defect is genetically influenced. So why don't us do the next best thing? We acquire genetic information from these fish, build a genetic database, and spend long hours screening for mutations that could contribute to these defects. And after long hours and sleepless night and a lot of coffee, I identified 11 genes. I was so happy. And the day of discovery, when I told my PI this news, she was so elated. At least we figured something out. Then it dawned on us, genes do not live in isolation. They interact. So, to better understand what is going on, we need to dive deeper into the gene interactions and networks so that we can know how these mutations directly or indirectly affect our interactions. Though the path ahead may be extremely long, which I can tell you for a fact it's going to be very long, but our perseverance is driven by a singular purpose, which is to ultimately unravel the mysteries of congenital heart defect with the hope of paving way for better therapeutics. It is this purpose in heart that fuels my scientific endeavor to improve lives and bring renewed hope to families affected by these conditions. This is our story, and this is the purpose in heart. Thank you.